Unit 6, Lesson 5. Angles of elevation and depression are applications to real-world problems. Using trigonometry. For the opening exercise, from a point 120 meters away from a building, Serena measures the angle between the ground and the top of the building and finds that it measures 41 degrees. What is the height of the building? Round to the nearest meter. So Serena is 120 meters away from the building. That's always along the ground. And the height of the building is going to be the distance between the ground and the top of the building. So that's y. Using trigonometry and using the angle that's given 41 degrees, I can see that we're looking for the opposite side and we're given the value of the adjacent side. So the trig function that we're going to use is tangent. So the function of the angle, tangent of 41 degrees, is equal to the opposite, which is what we're looking for, y, over the adjacent of 120 meters. We're going to cross multiply, plug it into our calculator, thus finding y, which is serving as the height of the building. Make sure your calculator is in degree mode, floating 6 to 8. You're going to go to the home page, number 5 settings, number 2, and look at the angle. Once you've checked that, go ahead and plug it into your calculator, 120 tan 41, in the calculation icon. And following the instructions, it says round to the nearest meter. So that means I have 104 meters as the height of the building. Another way to describe the location of angles in real-world right triangle problems is the angle of elevation when looking up at the object, and the angle of depression when looking down at an object. Both are the angle found between the horizontal line of sight and the segment connecting the two objects. So as you can see, you've got two things, a dog and a bird. They both have a line of eyesight. Here's the eye level for the bird. Here's the eye level for the dog. But once the dog starts to look up at the bird, you get an angle of elevation created between its eye level and its angle of elevation. When you look up at the bird, its eyesight is up top here, which I've drawn in blue. But when the bird looks down at the dog, you've got an angle of depression that it creates. So as you can see, you've got two parallel lines, and you've got a transversal caused by the angle of depression, also the angle of elevation. So the question down below is asking, what do you think is true about the relationship between the angle of depression and the angle of elevation? And hopefully you are able to acknowledge that you do have in fact alternate interior angles that are created by the angle of depression and angle of elevation, and as a result you've got equal angles. Alternate interior angles are congruent, therefore angle of depression is equal to the angle of elevation. Example 2. A person measures the angle of depression from the top of a wall to a point on the ground. The point is located on level ground 62 feet from the base of the wall and the angle of depression is 52 degrees. To the nearest tenth, how far is the person from the point on the ground? First thing I would do is draw a picture. So let's draw a picture of a wall. And I have a person on top of that wall. Draw a little stick figure here. Oh, he's missing his hair. So the person measures the angle of depression from the top of the wall to the point on the ground. So that means I'm going to have a line of depression. And here's the line of sight for this person. The point is located on level ground 62 feet from the base of the wall. So level ground, this is the point right here, is located 62 feet from the base. And the angle of depression is 52 degrees. To the nearest tenth, how far is the person from the point on the ground? So how far the person is from the point on the ground is this line right here. That serves as the hypotenuse of a right triangle. And as we just took a look at before, the angle of depression is equal to the angle of elevation. We're going to need to assign that 52 degrees to inside that right triangle in order to set up our trig ratio. So the value of x is what I'm looking for. The side that's opposite the right angle is the hypotenuse. Across from the angle that we're talking about is the wall. And the only side that's left is the adjacent. So we're using the adjacent and the hypotenuse. That leads us to believe we're using the cosine function. So cosine of 52 degrees is equal to the adjacent 62 over the hypotenuse x. So since the variable is in the denominator, all we're going to do is switch the variable and the function of the angle. Plug that into your calculator and get an approximation rounded to the tenths place. Go ahead and do that now. Okay, and hopefully you got 100.7. If you did, great job. So the person is 100.7 feet from the point on the ground. So what we try to do is answer the question in terms of the problem. So once you find what the value is, you can go ahead and restate the answer in terms of the problem. If you have any questions on this, please don't hesitate to pause this at this time and ask me questions. Another example 1. A man standing on ground level is 1,000 feet away from the base of a 300-foot tall building. Find to the nearest degree the measure of the angle of elevation to the top of the building from the point on the ground where the man is standing. So the first thing I would do is draw a man on level ground. He is 1,000 feet away from the base of a 350-foot tall building. So here's my building. That is 350 feet tall. And my man is 1,000 feet away from it. I end up with a right triangle, and we're asked to find the nearest degree of the measure of angle of elevation, so that's going to be down here. So here's my hypotenuse from the man, or the angle that is. I've been given the opposite, and I've also been given the adjacent, so that deals with the tangent function. So tangent of the angle, which is what we're looking for, is equal to 350, the opposite side, over the adjacent side of 1,000. So since we're looking for this angle measure, we have to use its inverse function with the ratio of the sides, thus finding theta. And we're going to find to the nearest degree, so we're rounding to the nearest whole degree. Go ahead and put that in your calculator at this time. If you got 19 degrees, you're right on. Good job. So in context of the problem, I'm going to restate that. The measure of angle of elevation is 19 degrees. Example 3. Scott, whose eye level is 1.5 meters above the ground, stands 30 meters from a tree. The angle of elevation of a bird at the top of the tree is 36 degrees. How far above the ground is the bird? Round your answer to the nearest tenth of a meter. This is a trickier problem because we have Scott, who has a height of 1.5 meters above the ground. So his eye level is up higher, and the angle of elevation is between his line of sight to the bird. So here's the right triangle we're going to use. Okay, so we have 1.5 meters above the ground, which is the height of this guy. That's the same distance between here and here. The angle of elevation of a bird at the top of the tree is 36 degrees. That gets assigned to here. And above the ground stands 30 meters from a tree. So Scott stands 30 meters from the tree. So since Scott is 30 meters here, opposite sides are parallel here if you were to draw this rectangle. So we can assign it up here, and we're looking for x, and once we find x, we're going to add that to the 1.5 to find the entire distance of the bird from the ground. I know it's a little bit complicated, but you just have to visualize it. So again, we're focused on the line of sight of this right triangle, the angle of elevation, and the right triangle that's set up higher using the information that was given. So from the angle, we have x, which is the opposite side, and we also have the adjacent side of 30. So tangent of 36 is equal to the opposite x over the adjacent of 30. Cross multiply and get 30 tangent of 36. Go ahead and plug that into your calculator now, and we're going to round our answer to the nearest tenths plot. Awesome job if you got 21.8. Okay, so 21.8 gets added to 1.5 because it's how far above the ground the bird is. Ultimately, the answer is 23.3 meters. So back to answering this in the context of the problem. The bird is 23.3 meters above the ground. Example 4. Samuel is at the top of a tower and will ride down a zip line to a lower tower. The total vertical drop of the zip line is 40 feet. The zip line's angle of elevation from the lower tower is 11.5 degrees. To the nearest hundredth, how long is the zip line? So how long the zip line is x. The vertical drop of the zip line is 40 feet, and the angle of elevation is 11.5 degrees. Here's my right angle. So from the given angle, if you look across, we have the opposite side of 40. Opposite the 90-degree angle is the hypotenuse, so that means we're dealing with the sine function. So sine of 11.5 degrees is equal to opposite 40 over the hypotenuse x. So since x is in the denominator, I'm going to do a switcheroo and have x is equal to 40 divided by sine 11.5. Go ahead and plug this into your calculator now. Fantastic work if you got 200.63. So we go back and write a final statement. The zip line is 200.63 feet. Example 5. A man who is 5 feet 8 inches tall casts a shadow of 8 feet 6 inches. So I'm going to start there. I'm going to draw my man, my little stick figure, with a shadow. Assuming that the man is standing perpendicular to the ground, what is the angle of elevation from the end of the shadow to the top of the man's head? So I'm going to draw this diagonal line. My right triangle looks like this. So I'm going to change 5 foot 8 inches to all one unit. So I'm going to make it all in terms of inches. So 5 foot 8 inches is equal to 68 inches. We know that it's 12 inches per foot. So 5 times 12 is 60, plus the 8 inches equals 68 inches. If you're not sure what units you can convert to, that is given to you in the back of your Regents exam, and I'll provide you a copy of that in class. Also, we have 8 feet 6 inches, so 12 times 8 is 96, plus 6 is equal to 102 inches. Okay, so my shadow is 102 inches, and the height of my man is 68 inches, and we're being asked to find the angle of elevation to the nearest tenth of a degree. So that's this as the variable. I'm going to use theta. So we've got the opposite and the adjacent sides, so that means we're using the tangent function. So opposite is 68 over the adjacent of 102. Since I'm looking for the angle, I'm going to have to use the inverse function using the ratio 68 over 102, hence solving for the angle measure. And don't forget, you have to round to the nearest tenth of a degree. So go ahead and do that now. Yes, 33.7 is the correct answer. Okay, so write it in terms of the context of the problem. The answer is that the angle of elevation is 33.7 degrees. This concludes this lesson, so you're responsible for completing the associated homework. Hand that in as soon as possible for a grade.